So number one wants to give a whole bunch of different parts here. So first it wants you to take this statement, sophomores take driving lessons, write the if-then form. So again, yours does not have to be word for word like mine is. You could use contractions, but I went ahead and stated, if you are a sophomore, then you take driving lessons. Now you don't have to use the word you. You could have said, if a person is a sophomore, then they take driving lessons. So you could take out that noun there, or whatever, that pronoun, and change it as long as it makes sense grammatically. Then the next thing they wanted you to do was write the converse. So remember the converse, you're going to flip the order. So now I'm going to say, if you take driving lessons, then you are a sophomore. And then next wants the inverse. Remember, for the inverse, you're going to add in the word not, or make it the opposite. So here, if you are not a sophomore, then you do not take driving lessons. And then the contrapositive, remember, you're going to flip and negate. So really, we're using that converse and then negating it. So for the contrapositive, we are going to say that if you do not take driving lessons, then you are not a sophomore. So we flipped it and we put in not. So the next page says, decide if the statement about the diagram is true. So they're saying that ray BD, which is here, let me highlight this thing. So here is BD. It's saying that it bisects angle ABC. So ABC is here. And I can say that, yes, this is true, because notice the little congruency marks here. This indicates that these are congruent angles, and I know by definition that an angle bisector creates two congruent angles. So because of the congruent marks, I can say, yes, it's true. The next one.
Miss Corey,
Yes.
the congruency marks are different heights, though.
It doesn't matter. So as long as it has the same type of marking, that's fine. If this one would have had like two little lines, let me see if I can make this get bigger. So like if this one had two and this had one, then they would not be congruent. So it doesn't have to be, because I think the reason why they put them at different heights is if they put it all the way across, you might not be able to tell that they're two separate markings. So I think that's why they put it in here at different heights.
Thank you.
You're welcome. All right, number 3, it says to rewrite the definition as a biconditional. So normally, if it didn't tell you, just to go ahead and write it, remember, you have to double check that the original statement is true and the converse, but because they just told you to rewrite it and it's a definition, we can go ahead and just add in our words if and only if. Because remember, in a biconditional, it does not have the word if or then. Instead, it has in the middle here, if and only if. So we could say two angles are supplementary angles, and then we would put in here, if and only if their sum of the measures is 180. So be able to write a biconditional from a definition, from a conditional, be able to turn it into a biconditional. Everybody good on the 2.1 warm up? Okay, let's go to 2.2. This is where we covered inductive reasoning and those laws of logic. So this first question is using inductive reasoning, and it wants me to find the next number in the pattern. So what I need to do is look to see what happened at the beginning of the pattern and then continue it. So from 20 to 22, it looks like it was adding 2, then 22 to 25, add 3, 25 to 29, add 4, and then so on. And then to get the next number, we would add 6. So my next number in my pattern would be a 40. Now, when they ask you to provide a counterexample, you could either it's going to depend on the type of statement they've given you. In this case, if it has something to do with math, you can give your counterexample as a math problem. So here they said, if the sum of two numbers is positive, then the two numbers must be positive. So I looked for two numbers, and I wanted to prove that they both didn't have to be positive to get a positive sum. So I made one number negative and one number positive, and I still got a positive answer. So this proves it false. So that's my counterexample. It's just a sample answer. You could have had different ones. Now, when you're asked to make a conjecture, again, everybody's conjecture could be different. You're just coming up with some kind of statement about this graph. So from this, I could make the statement that the student will do about 11 hours of homework in week 11. So if you notice that this is probably, the end of the box is 10, so if you were to extend it, and then notice that it's continually increasing, you could make that statement. You could also say that the number of homework hours increased steadily. You could also say, hey, in week 4, they had 4 hours of homework. Any kind of statement that you would make based on the graph. Now let's talk about our laws of logic. So know the law of detachment and know the law of syllogism. So number 1 wants us to use the law of detachment to make a valid conclusion in the true situation. So the first statement is this: if two angles are complementary, then the sum of their measures is 90 degrees. That was your given statement. Now they're telling you that based off of this statement, C and D are complementary. What can you conclude? And then you can conclude that you would either say that C plus D equals 90, or you could say, in a number sentence, the measure of angle C plus the measure of angle D equals 90. Something that shows that when you added them, you get 90 degrees. Then syllogism, remember this is with the overlap, and you would cancel it out. Now, if you need to rearrange your sentences, you can, but you can't switch the order of the hypothesis and the conclusion. But here I didn't need to. So my first statement was, if water is at room temperature, then it's a liquid. Then the second statement was, if water is a liquid, then it is not frozen. Notice the two things that are going to cancel are, it is a liquid, it is a liquid. So then what you're doing is writing this hypothesis, which goes over to here also, with this conclusion. So if water is at room temperature, then it is not frozen. So you're going to cancel out that overlap, that conclusion of the first sentence and the hypothesis of the second. Now I know I got a lot of highlight on here. Let me see if I can. No, it's not going to let me erase. Okay. So for this one, Jeannie buys popcorn. Now, just to show you, we have a bunch of different sentences here. Right now, we're only talking about Jeannie. So let's get rid of the Joaquin stuff. I'm going to get rid of this. So now I have this statement here. If Jeannie does her homework, then she goes to the movies. Then it starts talking about Jeannie down here. If Jeannie goes to the movies, then she buys popcorn. So then what you're going to do is you're going to get rid of the overlap. She goes to the movies, she goes to the movies. And now, based off of this statement, Jeannie does her homework, then you can conclude by using the law of syllogism, if Jeannie does her homework, then she buys popcorn. And that's why it's true. So if it's better for you to rewrite the sentences separately so you can see it a little bit better, you can do that on the quiz. Then the next one, it says that if Jeannie goes to the movies, Joaquin goes to the movies. So let me erase this so I can see about Joaquin now. The only thing I know about Joaquin is if Joaquin goes to the movies, he buys popcorn. That's all I know. I don't know why he goes to the movies. I don't know that he goes to the movies when Jeannie goes to the movies. All I know is when he goes, he buys popcorn. So I can't conclude this. This is false. And then now the
And it's false because one isn't dependent on the other to go to the movies, right?
Right. All we know is he buys popcorn. We don't know if he goes because Jeannie goes. They're not related.
Thank you.
You're welcome. All right, let's try 2-3. It says, use the diagram to write an example of postulate 2.3. Again, this number's not important to us, but again, if you go to Canvas and in the general information module, remember I have posted that theorem and postulate file, and in there it tells you all the names for the postulates. So this one is the line intersection postulate. And in here in green, I've written what it states. And that line intersection postulate states, if two lines intersect, then their intersection is exactly 1 point. So it says so you didn't need to put this as your answer. I just wanted to tell you what it said. What you are including is this. They wanted a specific statement based on the diagram. So here, my specific statement showing that when two lines intersect, their intersection is exactly 1 point. I'm stating that line FJ, this one here, and the intersection of, along with EG, their intersection is point F.
Miss Corey,
Yes.
can you name those lines, line M and line N?
Yes. So you could have also said, let me do this in white so it shows up. You could have also said line N intersects line M at point F. Yes. Because notice in the little picture here, they've got an M here, which is, it's a lowercase m, and then it's lowercase n is for the blue line. So yes, you can either name it with the 2 points or that lowercase letter. Absolutely. All right, and then number 2, decide whether the statement two planes can intersect in exactly 1 point is true or false. And again, by our postulate, we know that their intersection is always a line. It's not going to be at a point. So this one was false. And then the last one. It says, use the diagram to determine if the statements are true or false. The intersection of planes M and N is points B, E, and H. So remember, the intersection of two planes is always a line, so we would say false, because it's only saying, is it at this point, and this point? It's not saying that they are connected. And then GH lies in plane M, and I know I didn't fill that out, but here's GH. Let me do this in a color that shows up. And you can see that it is in that plane, so true. And then the last one, ABE, let me go ahead and highlight that, which is right here, this angle, and HED, this one, it says, are they vertical angles? Maybe I shouldn't do it with highlight. Let me do it with the pencil. So ABE is here, this angle, and then this one. It says, are they vertical? And this is false. They need to share a vertex. So they need to look like these angles right here. Now, if they would have said from this picture, If they would have said AEB along with the HED, then those would have been vertical. So we could say AEB and HED, those would have been vertical angles. So for the quiz tomorrow, it's probably going to be 10 questions. Know these postulates, be able to look at a diagram and answer questions based on those postulates that we learned in 2.3. Know everything that we learned as far as the logic goes. Know how to write an if-then statement, a converse, an inverse, a contrapositive, a biconditional. And then also know how to give a counterexample. So be able to just review this warm-up. You also have that other quiz review, and then also review your notes and your homeworks. So quiz tomorrow. You won't be given the entire class period because it's going to be a short quiz. I think the longest part might be writing out sentences on any of the free response. So for most of these, you should be able to type in your answers. You shouldn't have to tell me, see my work. So you should be able to type in answers on this. Again, remember you need 2 devices. So if you do not have 2 devices, you're going to be taking your quiz on a piece of paper and you'll use your iPad as your camera. So you must have your camera on for the entire quiz. If for some reason you're having technical difficulties, we can schedule a makeup or you can just do it on a piece of paper. So that is it. And I think I'm out of time. It's 12:30. Any questions?